Hi, welcome to another empowered video. Today we're going to do a deep dive into Infoblox high availability pairs. First, let's talk about grid communications. The center of an Infoblox grid is the grid master. Each of the member appliances talk to the grid master to receive configuration updates and software updates. The protocol used is called block sync. Block sync is sent over secure SSL tunnels between the grid master and the members. What is an HA pair? An HA pair are two appliances connected together, acting in concert as a single appliance, referenced by a single IP address. For communications between the two nodes of the HA pair, Infoblox uses the industry standard Virtual Router Redundancy Protocol, or VRRP. VRRP uses a fixed multicast address and a fixed MAC address. The final two digits of FF is reserved for the active unit, and the passive unit uses a unique identifier identifying this pair on the LAN. This is called the Virtual Router ID. It's a number between 1 and 254. Grid communications such as database updates come from the grid master over the block sync SSL tunnel to the LAN 1 port of the active unit of the HA pair. It then in turn passes that update on from its HA port to the LAN 1 port of the passive unit, again using the SSL tunnel of the block sync connection. VRRP advertisements, such as heartbeats, travel from the HA port of the active unit to the HA port of the passive unit outside of the SSL tunnel, using the virtual MAC addresses from VRRP. The VRRP advertisements from the active unit's HA port to the passive unit's HA port are done over layer 2 between the two virtual MAC addresses that are part of the VRRP protocol. This layer 2 requirement forces that all IP addresses must be on the same subnet. This includes LAN 1 and HA for the active unit, LAN 1 and HA for the passive unit, and the virtual IP that's shared between the two units. In some cases, such as a hardware swap, you may want to force failover the two units such that the active unit becomes the passive unit and the passive unit becomes the active unit. The grid master will send an update to the active unit to its LAN 1 port, and the active unit will then pass that on to the LAN 1 port of the passive unit. This tells the two units to switch roles. And when it switches roles, the MAC addresses associated with VRRP also switch. The FF MAC address now goes to the newly activated active unit. The ownership of the virtual IP also changes to the HA port of the new active unit. Another scenario that forces failover is when the active peer becomes unavailable. When such a thing occurs, the passive peer must now promote itself into the active role, taking control of the virtual IP that is shared between the two units. This situation occurs when the passive unit fails to receive 3 VRRP advertisements in a row over the HA interface. Advertisements are 1 second apart. The unit then over the block sync connection notifies the grid master of the situation. It now promotes itself into the master role and assumes the dedicated MAC address reserved for the active unit ending in FF. It then assumes control of the virtual IP over its HA port. When the new unit comes online, it immediately contacts the grid master, at which point the grid master sends it the configuration for the unit that previously failed. It assumes the VRRP fixed MAC address with the VR ID attached at the end. The active unit immediately starts sending it VRRP advertisements.